Hello everyone, welcome back to my channel. I hope you are doing great today. For some time now, we've been talking about table space and data files. But in today's lesson, we're going to look at how to manage storage space. First of all, we know that if you enable OMF, that's Oracle Managed Files, at the time of database creation or when you're doing your software installation, as a DBA, you don't need to bother about file names or storage requirements because Oracle will manage all of this for you. Again, let's not forget that data is saved in blocks, and then a collection of blocks form what is known as extent, and a collection of extent form what is known as segment. This is how your data is saved. Now, I've seen a couple of DBAs or some developers, make this mistake. Assuming a particular table is no longer needed and you want to delete data from that table, some developers use the delete from table statement, thinking that they've gotten rid of a table structure. But I can assure you that if you use the delete statement, the record may have been deleted, but the structure of the table still remains. And what that means is that the blocks and extent and segment still remain as though the table still exists. And our goal is to actually manage space. So how do we make the database reclaim this space for our deleted tables? This is what we want to talk about today. So let's jump right into my screen as I walk you through the process. For a start, you can see that my database is up and running, and you can see that we have two pluggable databases that we've created, one during installation and another one we created when we were doing our lesson for table spaces and data files, right? So let me quickly move out of this. To save our time, I've scripted some SQL statements and commands that we will be using, for our practice as I walk you through the process. So look carefully as I take you through this process. Now we're going to create another table space for this practice. Okay, so I'm sure you're already familiar with this command, show user, show container underscore name, but let's just be sure that we are in the right container. Let's look at who is logged in first of all. So we have the pluggable database administrator, that's TBS PDB underscore admin. This is the database administrator for this pluggable database, TBS PDB, right? Okay, so needless to run this command, show con underscore name, you should know by now which container we are logged into, okay? But for benefit of those that do not know, if we run this command, it will show us the current container, which is this, okay? So let's go ahead and create the table space. Create table space TBS E3. I'll execute this, and then the table space has been created. To verify, we can run this command, select all from DBA underscore table spaces where table space underscore name is equal to TBS E3. Execute, and you can see the table space. You can see the block size, 8 kilobytes, and this is the default size. And then the next thing we want to do is to create a user that will create objects in this table space, okay? The goal is to create a table, populate the table, and then later delete data and then see what happens to the structure of the table, okay? And then I'll tell you what the best solution is when you want to delete data from a table and when you want to delete a table, right? So we'll go ahead and create this user. Create user Abe, identified by Abe. Default table space is TBS-E3. So we'll create this user and assign the table space we just created to the user. So user Abe has been created successfully. Now the next thing we want to do is to grant the create session privilege, create table, and unlimited space to the user Abe. So let's execute this command. Grant create session, create table, unlimited table space to Abe. I'll quickly execute and then grant succeeded, as you can see from our script output. And then to confirm, you can actually use this query to know if the user actually exists, select all from DBA_users where username is equal to Abe. Okay, so if you execute this, you can see that the user exists. Okay, and you can see the default table space is TBSE3. Temporal table space is temp. Now, the database administrator will go ahead and create a table in Abe's schema. That's the table we'll be working with. Create a table in Abe's schema. So for that, we'll create a table abe.pers. Now we are prefixing the table with the user because the person creating the table is the database administrator and that is not his schema. So he has to prefix the table with the user. So create table abe.pers, and then these are the details of the table. Per ID, data type is number, name varchar2, that's the data type, and then word, that's varchar2 as well, and then this is the length. So let's go ahead and create this table real quick. Table abe.pers created. Okay, so as usual, we would like to confirm that the table indeed has been created. To do that, you can run the query select all from DBA_tables where table_name is equal to pers and owner is equal to Abe. So if I execute this, we can see that the table exists. Now, this is where it gets interesting. If I run this query, select all from DBA_segment where owner is equal to Abe and segment_name is equal to pers. Let's see what the output is like. So you can see that up until now, the Oracle database did not create any segment. And that's because we've not populated this table with any data. Okay? So because there is no data available, no segment has been created by the database. So let's try and insert one record and see what happens. So we're going to run the command insert into abe.pers values, and then we put the values, put the number, and then put the name, and then the word, more like some description, right? Okay, so we have to execute this, and you can see one row inserted, right? So if we select from the DBA_segment, we'll observe that a segment has been created. So let's quickly execute this query again. It says select all from DBA_segment where owner is equal to Abe and segment_name is equal to pers. So we'll select this, execute. Okay, now you can see that we have a segment created. Okay, and then the header file is about 60. Segment type is table. Now let's go ahead and look at the details of the extent. Remember the relationship, okay? Blocks to extent to segment and then to table space. So if I execute this query, select all from DBA_extent where owner is equal to Abe and segment name is equal to pers. Let's see what the output looks like. From our output, you can see the extent ID is 0. And then we have 128 as a block ID. Now you can see the block size, 8 kilobytes. And then this is the value in bytes, right? So now we have a structure in our table. But then let's try to do one thing. Let's try to insert up to 1,000 records and see how this plays out. For that, we'll execute a small PL/SQL code. So this is a little procedure, PL/SQL procedure that we have to execute. It says for I in 1 to 1,000 loop insert into abe.pers values. Now what this will do, what this little procedure will do is to insert 1,000 records, right? Let's quickly execute this. You can see PL/SQL procedure successfully completed. Now let's run that query again to select everything from the DBA_segment. It says select all from DBA_segment where owner is equal to Abe and segment_name is equal to pers. And let's look at the output this time. Now, can you see that we have 16 blocks already? So as we insert more records, more blocks are being used. And then we already have two extents created. One extent for the first insert and then another extent for the second insert. Just follow me closely, we are getting somewhere. Now the next thing we want to try to do is to insert 1 million rows. And then let's see what the size of the block is. Let's see what the size of the extent is, right? So again, we're going to execute another PL SQL procedure. So let me quickly execute this. You can see that it's a little bit slow because of the amount of record we are trying to insert into the database. As you can see, PL SQL procedure successfully completed. Now, let us check the details of the segments and also the extent. So we'll run the same query we've been running again to check the segments. And one of the things you will observe from our query output is we now have 5,632 blocks, and then we have 59 extents. You see how the blocks keep growing. You see how the block sizes keep growing, and then the extents keep growing as well. In the same way, if you select the details of the extents by running this query we've always executed previously, select all from DBA_extent, where owner is equal to Abe and segment name is equal to pers. If you execute this, you will see that the block size is actually 888, and then after some time, the block size increased to 128, 128, you know, like that. Now that we've been able to populate our table, and then we can see how the extents keep growing, the segment keep growing. Let's now try to delete from the table. Let's assume that this table is no longer needed and we want to delete data. Now, this is what a lot of DBAs do, or a lot of developers. Okay, they will just type the command delete from abe.pers and commit. Truly, this will delete all the data, but the structure of the table still remains. And when that happens, the database will see it as though that segment is still being used. So if I do this, delete from abe.pers and then commit, you can see over 1 million rows deleted, virtually all the rows deleted, okay? But then if I execute this query again, select all from DBA_segments, where owner is equal to Abe and the rest of them, you can see that the structure of the table is still there, the segment is still there. You can see that the blocks is still being used. So that way we won't be able to reuse these blocks. So how do we reclaim this space? How do we reclaim these segments? Very simple. Instead of using the delete statement, use the truncate. If you want to reclaim any segment, if you want to reclaim unused space, unused table segments, please do not use the delete to delete all records from a table. Instead, use the truncate table, right? So let me go ahead and truncate this table. You can see table abe.pers truncated. Now, if I execute the query again, what do you observe? The blocks have been reclaimed, right? We have just one extent. Guys, can you see how this works? So this is just a little exercise to show to you how to delete data from a table that is no longer needed. So instead of using the delete, just go ahead and use the truncate. Thank you so much for watching this video. I hope it was interesting to you. If it was, kindly like it and share it widely. And most of all, do not forget to hit the subscribe button and turn on the notification bell so you don't miss out whenever I upload another valuable content. And I'll see you in my next video. Bye for now.